So we've got our point. What we need to write our vector equation of a line is any point and then a direction vector. And the vector 3i minus 4j, that means here's our origin. The I is your x coordinate, so you're going to go 3 in the x direction and 4 up. That's the direction that this graph is going. Because it's parallel, it's going to be exactly the same. Minus 4, and I did positive 4. Yeah. Here we go, 1, 2, 3, 4. There we go. 3 in the x direction, 4 down. That would be the vector 3i minus 4j. And that's its direction. That's the direction we're going in. So our vector equation, our point is 2, 5. And our direction is 3, negative 4. I'll just quickly write the parametric and the Cartesian forms. So the parametric are just your x coordinates and your y coordinates. So your x coordinate is going to be 2 plus 3t. And your y coordinate is going to be 5 minus 4t. If you solved for t in both of these, one of them would be x minus 2 over 3, and the other one would be y minus 5 over negative 4. Make those equal, and you have your Cartesian form. So what does this mean as far as how does this align in what we've done in the past? Well, first of all, we know a point on that line. We know that it has 2, 5. So there's 2, 5. We know that it's going in the same direction as 3, negative 4. So if I went over 3 and down 4, what point would I get to? 5, 1. So this is the actual line that we're talking about. If you wanted to write that as y equals mx plus b, we know that the slope is rise of 4, run of 3, negative 4 over 3, right? Notice how similar the slope is to this part of our equation. It's just flipped because we have x coordinates on top and y on the bottom. So we sort of have run over rise instead of rise over run. If you wanted to, you could work backwards and find out what this y-intercept is and write y equals mx plus b. But the way that this equation here works is you can put in any value for t that you would like. So let's put t as 1. That would make this just 3 minus 4. Look what happens. 2 plus 3 gives us our 5. 5 plus a negative 4 gives us our 1. So that tells us one of our points. If you did this direction vector twice, so if t was 2, then you'd find the next point down here. If you made t a half, you would find this point right in between. So this is what I was describing before. Sometimes it's a little bit harder when you don't have an actual example. But this is just a starting point, and then you can go in this direction as much or as little as you want. If I wanted to find a point backwards, then my t value becomes negative. And that'll give me points backwards. Okay? Once you get your parametric changes back into Cartesian. And once you have your Cartesian, can you see that if you wanted to, we could simplify this? What would happen if I multiply both sides by 3 and 4 to get rid of fractions, sort of cross multiply? I'm going to get negative 4x plus 8 equals 3y minus 15. If I got y by itself by adding 15 to both sides, I get 3y equals negative 4x plus 23. And if I divided this by 3, I get y equals mx plus b. Right back to where we were in grade 10 and 11 math. But the b value isn't a nice looking one. And so dealing with the equation y equals negative 4/3 x plus 23 over 3 as your equation of a line, you're always going to be dealing with fractions. Dealing with the vector equation, we've got a lot of nice numbers that we can work with. So it's pretty easy to figure out. Okay? If you wanted to find something like the y-intercept, how do you find a y-intercept? X equals 0. You could go to your parametric equation, put x equals to 0, and find out what t is. T will be negative 2/3. Then you could plug in negative 2/3 for t and find out that the point would actually be 23 over 3. So just how all of these things are connected.